My name's Dan. I am the head of engineering at Trainline. I'm not the head of engineering at Trainline, I'm a head of engineering at Trainline, and I look after the data and BI functions. So, through my career, I've worked, well, in these three places mainly, but in many places where I've seen people doing stuff with data. But I think what we always talk about with doing stuff with data is always very different with what we actually do when we're working with data. So we like to talk about neural networks and training classifiers and doing cool stuff, but what we actually do is just collect data and put it in a bucket somewhere. And I think there's patterns within that world in which we live that repeat over and over again. And hopefully some of the ones that I talk through today will resonate with you. And hopefully there'll be some advice that you can take away and use in your lives elsewhere. So in the three places that I've worked in the past, the data has been very different in the kind of shape and size. So the first place where I started working with large-scale data was this company called Viavi, who you won't have heard of. But something like a quarter of all internet traffic runs through boxes that they create, and they're very keen to do analytics on that data and tell you about what's happening on the network, mobile phone networks, internet, that kind of thing. So we were processing billions of rows per hour on reasonably small clusters that all had to be hosted on-prem. So it was a very weird and bespoke kind of a world that we lived in. Then I moved on to Compare the Market. I guess you've all heard of Compare the Market. Certainly if you watch Coronation Street, you'll have heard of them. So no, yeah, fair. It's a fair observation. At Compare the Market, all the data was originated by people with no training and with no checks and no QA, because it's just people who are on the internet typing data into forms. Sometimes those forms have got like 100 questions in them. So there wasn't a huge amount of data because there weren't an infinite number of people typing it, but it was really messy and, really, really bad quality. And so to draw any insights from it was a real challenge. Then I moved to Trainline, obviously the best of the three by a country mile, where we work with travel data. And I guess Trainline's kind of main selling point is the fact that we make something that's very complicated, booking a ticket from one place to another, into something that's very easy by pulling together travel data from all sorts of operators so that you can book tickets anywhere in Europe on our platform, and you don't have to worry about which website to go to or which travel protocol to use or where to change or anything like that. All those sound very different, but in actual fact, what I've been doing in my day-to-day life has been pretty much the same for the last 7 years. But enough about that. So today I want to talk about the curse of legacy data, because I think what most of us are actually doing is either dealing with a legacy of data or creating a legacy of data, or maybe both. And it can be a curse if you don't do it right. So like I said before, we all like to get together and we all like to talk about the cool stuff that we're doing with data. But the reality is often less glamorous. So I don't know. I mean, in Trainline and in other companies where I've worked, we have a big relational database that stores all of our sort of company information. I don't think that's anything to be embarrassed about. Trainline's a 20-year-old company, so that's had a very rich history as it's kind of grown up through the years. That was exactly the same at Compare the Market, exactly the same at the place before. Everybody's got one. There's no shame in that. I don't know, hands up anybody else who has an annoying legacy database that they have to get data from. Thank you. Thanks to the few who are honest, the few who are too embarrassed to talk about it, and the few who have worked for a startup or have just graduated or something. And that's the point. So companies kind of 10, 15 years ago, and startups today are working in a very different way to companies the size of Compare the Market and Trainline and things like that. They work because they're driven by getting stuff done, or because they were bound by the technology that they had at the time. So the architecture of what they're doing generally looks like this. It's an application talking to a database. And if you work for a startup now and that's what you're doing, that's great, because you're probably going to sell whatever it is you're going to sell a lot quicker. You don't want to be sat there with an application talking to 20 boxes making this really complicated, extensible data platform, because your customers aren't going to wait for you to finish that off. But as time goes by, the database is going to get bigger and more complicated, and you're going to add more tables, and you're going to, add more stored procedures, and it's going to get more and more difficult to manage. So it's not wrong that you arrived where you arrived, but you start to develop a problem. Then you'll start wanting to do like reporting and insights and showing execs dashboards, or maybe doing a bit of an analytics or doing a bit of training a neural network or whatever. You can't do that on the production database. You will invariably end up with another database that you back data up to overnight, every night, and sometimes that goes wrong and you have to send an email saying, I'm really sorry, there are no reports today. You all know the drill, except the ones who just graduated. So, and you will. Some of us, hands up if you're working on a cool real-time application, perhaps using something like Apache Kafka or Flink or something. We are too, and it's brilliant, and it's genuinely revolutionized the world of data. But that pattern's still there around it. It's happening alongside what we've been doing for years and years. That doesn't mean it's bad, but we're not part of it. There's two worlds emerging in the companies that we're working in. And likewise, if you're doing cool data science, hands up if you're doing cool data science. Yes, Tim. Yeah. Cool data science applications in production. That's fantastic. And we have some of those, and I am genuinely incredibly proud to work on them. And they kind of hang off the side of that main sort of workflow, and they sometimes ingest data sources that aren't part of that kind of centralized model that the company is using. So what's the problem with that, other than the fact that we like to be the center of everything that's happening and feel important? Well, it's probably a relational database, and even if you've put it in the cloud, or even if you've used something like Cassandra, you're still going to have problems with scaling. Maybe it's in an on-prem server room, or maybe it's some of the fans are broken on the CPU board or something like that, I don't know. But you're going to start struggling with performance because all your eggs are very much in one basket. Because you haven't got this kind of pure horizontal scalability, because it's probably a relational database. And over and above that kind of sort of performance impact, software systems that have been around for a long time start to become actively resistant to change. And I think this is something that's been a real theme throughout my career, is that it becomes harder and harder and harder to make changes in these systems, not because they were badly architected or badly designed, but just because they've got more and more complicated. They've been built on and built on and built on until everything is sewn so tightly together. Circular dependencies might be in there. Absolutely everything they do is hypercritical, so you can't turn anything off. They're ludicrously complicated. It's really difficult if you try and replace something they do with data that's outside of that system to then reconcile it back to what those systems are doing. And of course, everyone's left who worked on it originally. So what are we going to do to get out of it? We feel like we must get out of this together. What are we going to do to get out of it? My fonts have gone all horribly wrong on this presentation. There was a pirate font there. It took me hours to find that. So there are two important things that we need to do as we move forward. Firstly, don't do it again. Secondly, try and actually move forward. Try and actually get off the old database. So we're going to talk about not building it again. This, oh, look at that font. That says real time on the blue bit and batch on the green bit. This is almost certainly your data architecture. I've been to know enough of these meetups to know that this is what everybody's doing nowadays. Everybody's ingesting some data, perhaps to a REST endpoint up there on the top right, maybe coming in from the outside world. Everybody's pushing that to Kafka. If you're using any other real-time streaming platform, consider conforming with the rest of society. Everybody's probably doing some cool stuff with something like Kafka Streams. Everybody's processing that stream of data, because it's ludicrous not to be doing that kind of stuff these days, because it's so very powerful. And if you want to then serve that back up to the front end in real time, you're probably using some kind of cache database so that you can communicate with them without letting them into your precious streaming system. All great stuff. Everybody's then writing that data into a big data lake. It'd be silly to throw it away, wouldn't it? They're probably projecting into kind of lakeshore data marts or whatever, and they're serving that up via reporting. And they're maybe allowing some kind of ad hoc analytics over that data lake as well. So here's some logos. Kafka, we mentioned that. Maybe you're using something like DynamoDB, or maybe Cassandra for your kind of fast access for the front end. Maybe something like Redis. I can't remember what that is. Oh, S3. Maybe this is like an icon challenge. Maybe, maybe you're using S3 for your data lake. Maybe you're using BigQuery. There's only two. I don't. Maybe Microsoft have an offering. Yeah. Okay. Maybe using Redshift for some of your data marts, or maybe using Cassandra again, or maybe using something else. Maybe Athena or BigQuery again for your analytics work. Tableau and Looker are great reporting tools. Anybody want to shout any obvious things that are missing? No. Spark. Yeah, fair point, actually. Fair point. It might be that you're going from that data lake to those marts with Spark, or you might... Sorry? Yeah, scheduling tools are fair enough. That's true. So we're all working with things like that. That's a very fair point, but I see those as being kind of a different plane of existence. But you're absolutely right. So we're all using Airflow. So you have to optimize when you're working with these things. Remember, we're talking about how to do this and not end up in the situation that we did before. You have to think in different dimensions when you're working on different parts of this architecture. In the streaming world, you have to optimize for speed, because that's the point of doing streaming. So everything you do needs to be built for speed. You probably want to be using a JVM language and not Python. You probably want to be using, Kafka and all those things. Everything needs to be done as quickly as possible, because your customers operate in real time and you need to operate in real time too. When it comes to the reporting tools and the analytics, you absolutely need to be optimizing for the experience of the people who are using that. They don't mind if they wait a couple of seconds longer for the report to load, as long as the report looks pretty and they can do something interesting with it. And when you're storing data, certainly at the volumes that we store data here and have stored data elsewhere, it's definitely cost. If you start to mix these concerns up, you'll make terrible decisions. If you start optimizing your data lake for speed, weird stuff is going to start happening. You'll make really odd design decisions that are going to drive you, crazy, or the people who come after you as you head off into the distance. I guess the other point that's almost too obvious to point out is that you probably want to use something that's quite scalable. So there's an Oracle Exadata on the right there, which I have in the past compared to a Bugatti Chiron, in that it's very flashy and fast. It costs about the same amount of money, and it's great. But if you just want to pop to Tesco's or go down to B&Q to buy a plant pot, it's not really very useful. What's more useful is getting an Uber or hiring a van. Now, if you go everywhere in your life in a hire car or in an Uber, you're probably going to spend quite a lot of money. And over your life, it's probably going to add up to the price of a Bugatti Chiron. So I guess it's not about cost here, it's about that horizontal scalability. What was I going to say about this? Can't remember. Oh yeah, that. So the other thing that I think went wrong in that original database that we're all using is that we started to implement kind of systems that became unpredictable. So things would happen that not really anybody understood, and certainly as people left the building, we'd lose knowledge and it would disappear, and it was somehow not encoded in the code anymore. Somehow the database became sentient and started to think for itself. And the reason for that, I think, is something like along these lines. So imagine a system that takes transactions and turns them into orders. I don't mind what kind of transactions, certainly not railway tickets, but some kind of job that turns transactions into orders. It's easy to understand that. You could write a unit test across it. You take n transactions and out you get n orders out the other side. So you process Monday's transactions, and that's great. And then you process Tuesday's transactions, and you update those into the table along with Monday's transactions, and all your transactions are up to date. And you do the same thing on Wednesday, and that's all fantastic. Except the job was wrong. So on Tuesday, somebody committed some code that broke that job that was updating your table. What do you do? How can you fix that data? You can't roll it back because it's got Wednesday's data in there and Monday's data. It ran. the data is different, and because it changed every day, it's pretty much impossible to unpick it unless you get somebody to stare at it for ages and write SQL until it's all better. And that happens a lot. I think we've all been in that situation, right? So it's far better to stop doing that kind of stuff and start to just do it a more sensible kind of Spark style, Hadoop style way, where you don't, every operation that you do is repeatable. So you process the Monday transactions into the orders that existed on Monday. Even if you have to process every transaction in the history of the company, you do that and you produce a set of orders, and it's a true set of orders. Then you do the same thing on Tuesday. You throw away Monday's data and you do it again, and then you do the same thing on Wednesday. And the great thing is there, when Tuesday went wrong, it doesn't matter because you can just roll back, fix the code, and run it again, and you get the same thing out. All the code is idempotent and deterministic, and all the data is immutable. And that's a really important sort of philosophy. I know a lot of people are going, yeah, I know this. And there are a lot of people who know it. And it's a foundational kind of idea about what we all do for a living. But the number of people I have to explain it to made me feel like it was probably worth pointing out. So stick with that, and stick with the languages that encourage that behavior as well. So we use Clojure here, but I've worked with Scala in the past. So functional languages build this kind of thinking into people's heads, whether they like it or not. Orders are regeneratable there. Job A is perfectly unit testable. The unit tests become the documentation. When Jeff, who wrote the job, leaves the company, it's fine because you still know how it works and you can still recreate it. I think the other big problem that we all made, or have all seen made with these big databases, is conformity for the sake of conformity. So here's that job again. Transactions turn into orders, and then there are two reports. One of the reports was created by somebody from this decade. The other report was from the 1990s, I think. Those two reports both rely on the orders table. But we need to change one of them. So we need to maybe change the way that we're calculating the orders, but only for the line chart and not for the bar chart, for the pie chart, sorry. So maybe somebody in the business just wants to see their report a different way. And what that would have meant in the past is that we have to change this job B and we have to change job A, and then the orders table is different, but then we have to go and change job C as well to make sure it's showing the data it used to be showing as before we made the change. Imagine if there are 100 reports hanging off this. You become sort of paralyzed by an inability to kind of make changes. So the answer is to just not conform. Nobody told you could only have one orders table. So branch the data like that, create a new job, aggregate orders into a different bunch of orders, and then you've got this problem solved. Everything else runs off the old table. Regeneratable again, unit testable again, super duper. It assumes storage is free, but storage is cheap. It's cheaper than developers anyway, so you should be all right with doing that. The other thing that I think is important when you're building this system that isn't going to be terrible is to use patterns you can execute on quickly. Speed of delivery of products is an incredibly important thing. So here we use three broad sort of patterns that we can kind of repeat, and we try and optimize the development of solutions against those patterns so they're as fast as possible. So if we want to do a streaming app, we use those things. We use those bits. So we'll only have to work on those areas, and we'll basically write the code so that there's minimal sort of requirement of effort to go into it to build out a fast streaming solution. Likewise, if we want to get data into a report, there's certain places through the flow that we'll have to touch, and we'll get our report changed. And the emphasis there is on only touching those areas, keeping them nice and isolated, and using libraries and things to go around and make sure that work happens quickly. And then if you want to do analytics, it's pretty much the same flow as before. So you get the idea. You use patterns that you're able to execute, optimize the delivery of those patterns, which is fantastic, but it inevitably leads to a very common mistake that I think developers make, which is that they don't like writing code, or they like writing code a lot more than they think they do, maybe. So developers find themselves executing the same pattern over and over again. What will they do? They will say, well, this should be a config file. I'm going to make a config file instead, because then I won't have to write the code, and it'll be loads quicker. So they write a config file, and then something subtle changes about the next job that comes along, and the config language that they've designed to do it doesn't support the new features that they need to put in. So they end up, over a period of about 6 months, building a Turing-complete programming language where their config file used to be, and then moaning that they have to do this config because they enjoy writing code better. Everywhere I have worked, this pattern is repeated. We've ended up with config files that become languages. You can just inject some Python into this bit of the config and that'll execute against the thing. So just don't. Just use Python. And I think one of the great things about Airflow, thanks for bringing that up earlier, is that it's very much showing you how to do that. All the properties that I've been through so far are in Airflow, which uses Python, because Python is just as good a config language as anything else. Okay? Good. Second thing, get off the old database. Has anybody successfully migrated off an old data platform in their career? Yes. Well done. I've migrated off a new data platform. There's a horrible story. It wasn't here. So it's really, really difficult to get off this old thing. Let's imagine that we've built a beautiful new thing. We've got a wonderful data platform, and we've built it. We followed all my advice, plus the advice of much cleverer people, and we built it. It's great. We've still got to get rid of the old thing. And remember that the old thing is still very resistant to change. It's still used by everybody across the business, and it's still incredibly important to everyone. So what our managers or execs will inevitably ask for is a plan, normally in the form of a 1990s Microsoft project sort of Gantt chart. When are you going to be off? When can I turn it off? Which bit are you going to move first? And so on. And I think, in my experience, that has become almost an impossible task, because you have to understand everything before you can start making that plan. And it almost takes longer to do that than it does to do the work. So instead, my advice would be to track a KPI. So rather than making a plan, just commit to do it and then track your progress through doing it. So your KPI might be the number of users using your old platform every day compared to the number of users using your new platform every day. And that's a really nice KPI to optimize against, because it's very relatable for the exec. You can go and sit in front of the exec and go, oh, this is brilliant. 100 more people are now using the new platform than were using the old platform. They understand that. They can relate to it. And it might be enough to make them forget that they wanted a Gantt chart in the first place. It's also a lot easier than making that plan, because it didn't take me very long to come up with this one to put on this slide, and it probably won't take you very long. You could look at using something like IOPS in the database, or amount of money that you're spending, or whatever it might be. And then once you've done that, once you've got that KPI and you're able to track your progress through, just carefully move one thing at a time, like really carefully. Just pick something and move it. Move it to a new place and go through all the pain, and then pick the next thing and the next thing, and they will inevitably get easier and easier and easier until you're done. But how do you pick those things? This is a beautiful chart that basically shows common sense using a graph. So if you think of this graph, there's a complexity axis there, and there's a accuracy axis there. So some reports are incredibly difficult to reproduce and some are incredibly easy, and that's one constraint you need to think about. And the blue dots there represent like reports or applications or things. More importantly, I think some are very easy to move because nobody cares if they're right, because they're just, I don't know, they're on a TV in reception or something like that. Others are incredibly important because maybe they're used for your financial reporting to whoever owns the company, or maybe they, whatever it might be. And if you're wrong by 0.001% on one of those, then you're going to be in really deep trouble. So don't start with those. Start with the easy ones. Start with the smallest, least accurate report you can find, and move that. I've made it look like the Windows logo to further explain this point. So start with the low complexity, low accuracy reports. You might want to pick one that people like using as well. And just do them. Just start moving them. and happily move people across. The ones that are much more complex, but still but don't have much of a requirement for accuracy, so the blue box there, really think about why you're doing them. Like, if they don't need to be that accurate, and they're also ludicrously complicated, who is using them and why? Like, yeah, it's fine to have simple sort of applications and reports that don't need to be accurate because they just give you a view. But really, really complicated things that are also really, really a bit wrong sometimes is not somewhere that you want to be. So maybe just don't do them, just throw them away. And your KPI will get better as a result. On the ones that are very high accuracy and not too complicated, make a friend who uses it and never ever let them go anywhere until you're done. Like, sit next to them and just work with them, proper agile style, until that application's been moved. And for the really big ones that are really big and really complicated, we all have them, some ludicrous application. Just break it up into chunks, put it off till later, come back when you've finished all the others and start to break those down and repeat the whole process again. And the final thing I will say is that you should know when to stop. So the other mistake that people make when doing this kind of migration is that it starts to become like a vendetta, like some kind of, like we've got this thing, we need to move away from it. Why? Because I hate it, because it's not the new platform, it's legacy. Well, yeah, maybe, but that's not the business reason why you're doing it. Businesses rarely make money because you're just angry at Oracle. Well, actually, maybe AWS, I don't know. Anyway, but so you'll get to a point where maybe there are some of those from the red box there, some ludicrously complicated application that's really, really needs to be kept accurate, that maybe it's used by really important people, and maybe it's okay to leave it where it is. Maybe you can move it into the cloud, chuck it in like an RDS instance or whatever Google's equivalent is, and leave it there, and accept that maybe your business goal isn't to destroy all relational databases, but just to make you have a better data platform. So I was going to take my own advice there before I literally melt and stop. So thank you very much.